What we're doing is we're looking for the origin of something called cosmic rays. Cosmic rays are very energetic charged particles that pass through our heads all the time. It's about 5 per second going through the tops of our heads every day, and we would like to know where they come from. The difficulty is that because these particles have an electric charge, when they meet the magnetic field in the galaxy, their directional information is lost. They get tangled up, and we can't tell where they come from. But the one thing we do know is that wherever these particles are accelerated, gamma rays will also be produced. And so by looking for the gamma rays, which are just a form of light and don't care about the magnetic field, we can use them to trace where the cosmic rays come from. The waves can't get away, so they all pile up. Now, anybody who's ever been in a boat has seen this, right? Gamma rays are very energetic and they don't reach the Earth's surface, which is good for us because otherwise we would all be fried, which would be embarrassing. But from the point of view of an astronomer, it's a right pain because they're difficult to detect. The way in which we actually do it is when a gamma ray comes into the upper atmosphere, it produces a cascade of subatomic particles. And these particles are moving faster than the speed of light in air, not faster than the speed of light in a vacuum, which would violate several laws of physics. But when they do that, they create a kind of wake of electromagnetic radiation in the atmosphere. So what we've had to do is try and explain how this occurs. So what we've done is we've used a train, which moves a little dip around in water, to create a water wake, which is something with which most people are familiar.
Gamma ray astronomy is a really new field that is opening a window on a whole new type of radiation. It's the highest radiation that's produced in the universe. This is a really exciting time that we're discovering new sources, and a lot of these sources haven't even been discovered in other wavelengths. So this is kind of opening a whole new window on astronomy in general. So what we do, we have to come up with a clever way to detect gamma rays on the ground.
Well, the team with which we work is called HESS, which stands for High Energy Stereoscopic System. And it's a major team of scientists from across Europe. There's about 100 of us involved. Key tools are the gamma ray telescopes built by the HESS collaboration, and they're in Namibia in southwest Africa. Each one is 13 meters in diameter, consists of 382 individual mirrors, and has at the focus a detector weighing something over 1 metric ton. The point is that building telescopes like this is a very expensive operation, and that requires quite a lot of money. And so you really need a large collaboration of people across Europe to do this. But there's also the different skills of the different teams. So there's skills in engineering, there are skills in electronics, skills in what we do, which is atmospheric monitoring, that we bring together right the way across Europe to make the project work. The implication of this research really are to find out about a large part of the energy budget of the universe. The universe produces a lot of visible radiation that we can see. It also produces a lot of stuff that we can't see. And this is the really energetic stuff. What this gives us is a completely unique view of the universe and an understanding of where a lot of its energy actually goes and how it produces that energy.